so we have question from calculus 1 saying sketch the graph of f of x which is equal to cosine square x minus 1 on the interval, closed interval 0 to 2 pi using symmetry, intercepts, asymptotes, relative extrema, and points of inflection, and identify the open intervals in which the function is increasing or decreasing, concave up or down. So the first thing that we're looking for is symmetry. Y-axis, yes, there is symmetry on y-axis. No symmetry around the origin, no symmetry on the x-axis. Intercepts, x-intercept is 0, pi, 2, pi. Y-intercept is 0. So, what about the asymptotes? There are no asymptotes here in this function, which is cosine square x minus 1. So, no vertical asymptote, no horizontal asymptote. So now we first take the first derivative test. We derive the function which is equal to multiplied by negative sine square plus cosine square. We test for the intervals which we have the critical numbers already, and we check the intervals. So it's decreasing from 0 to pi over 2 and increasing from pi over 2 to pi, decreasing from pi to 3 pi over 2, and increasing from 3 pi over 2 to pi. Alright, now we find the extremas. Okay, so we plug in 0 into the original function, so we have 0, 0, and we plug in pi over 2 into the original function, we get pi over 2 negative 1. F of pi, we get pi 0. F of 3 pi over 2, we get 3 pi over 2, 1. F of 2 pi, we get 2 pi 0. So, those are our extrema. And according to this derivative test, which is the first derivative test, we know which ones are the absolute extrema or absolute minima and absolute maxima. Now we find the second derivative test. F double prime equal to sine square x minus cosine square x. We derive this. So, I mean, not derive, but let it equal to 0. So we find the potential points of inflection, which are pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. So, we have the second derivative. Now we check for concavity. From 0 to pi over 4, it's down. Pi to 3 pi over 4, it's up. 3 pi over 4 to 5 pi over 4, it's down. 5 pi over 4 to 7 pi over 4, it's up. 7 pi over 4 to 2 pi, it is concave down. Now, same thing, potential, or now we have points of inflection, so we plug in pi over 4 here, and 3 pi over 4 into the original function, 5 pi over 4 into the original function, 7 pi over 4 into the original function. We get those points of inflection. So, what's left is the graph. The graph of cosine square x minus 1 looks like this graph, which is from 0 to pi, we have the point of inflection pi over 4, negative 2. Negative half or negative 1 over 2, whatever. So guys, I'll let you take a final look on the graph to comprehend the points, the concavity, and digest the question in general. And if you want, we're gonna go back to the whole question all over again. We'll take a look at it. Alright? This is the second page. Actually, this is the first page. And this is the third page. This is the fourth page. And what's left is the graph. I hope that you got the idea of this question and will be beneficial for you in calculus in general, and thank you very much.